Okay, thank you. So I will start. Okay. So here we are given a causal linear time invariant system. Okay. So we have a system like this. Okay. And this will be a line time invariant system. And also this will be causal. Okay. This will be causal. Okay. And if we are given an input, let's say the input is xn, okay, and the system has impulse response hn, and we will have output yn. Okay, so from the basic definition, you know that yn is equal to, because this is a LTI system, linear time invariant system. Okay, so we can express the input as output as input convolved with impulse response. Okay, so if you get the Z transform, you will have YZ, XZ, and this convolution will become a multiplication. Okay, so that is the convolution property. Okay, so you have here HZ. Okay, so this is your response. Okay, in Z domain. Okay, this is your Z domain response. Okay, you can get the Z domain response through this. Okay, so Z is equal to YZ divided by XZ. Okay, actually this is the response. Okay, this is the Z domain response. Okay, okay. Now we have this knowledge. Okay, now okay, now we are given HZ. Okay, now we are given HZ. We are given the Z transform of this impulse response. Okay, Z transform of this impulse response we are given. We know that. Okay, so this one plus 3, 4 is at minus 1. Okay, now so our first question is find the impulse response of the system Hn. So find the Hn. Okay, so do you have any idea how to do this? How to do this? So I think we have to find the inverse transform. Okay, so here you have to find the inverse Z transform. No? Yeah, need to take the inverse Z transform. Good. Okay, so we have to take the inverse Z transform. Okay, actually if you have that idea, you will get some mark. Okay, you will get some mark. Okay, so if you know that to find the Hn, you should get the inverse transform of this one. Okay, then some marks will be added to you. Okay, okay, then the problem is how to find the inverse transform. Okay, so we have three methods. No, can you remember? We have three methods. The first method is the standard methods. What is that? Contour integration, contour integral. No, so this is our standard method. Any any inverse Z transformation can be evaluated through this. Okay, so this is the standard method. Okay, and we have seen other two shortcuts. Can you remember? One is using the power series, and other one is using the partial fraction. Okay, so these two are the shortcuts to find the inverse transform. Okay, actually here for both these we are using the definition of Z transform. Okay, we are using the definition of Z transform. We are using the definition of Z transform to evaluate the inverse Z transform. I hope you can remember. Okay, now So do you think which method should we use? Our series expansion or partial fraction method? What do you think? So what methods do you think we can use? Our series or partial fraction method? Okay, actually that is the answer I expect from you, partial fraction. Okay, partial fraction. Actually, if you in a examination, you said that we are going to use the partial fraction to evaluate this is a transform, then also you will get some marks. Okay, because you will then you have get the step. Okay, you have get the step. So it is uh, it is not the injustice to give you some marks, no, because you have get a step. Okay, so but here you can see that actually we no need to do the partial fraction. Okay, because uh, this can be right like this. Okay, without the partial fraction, this can be right like this. Okay, so here you have a numerator. No, this is numerator as I can remember. Okay, maybe the terms may be changed. Okay, this is the denominator. Okay, this is the denominator. Okay, so here you have a numerator sum. Okay, one denominator. Okay, but if you can remember, we need partial fraction if you have uh, several denominator product. If you have a product as a denominator, we are using the partial fraction. No? For example, can you remember that if you have this kind of one, a plus x, b minus x, b plus x. So here you are going to use the partial fraction method. Okay, so here you have a product. Okay, here you have a product. Okay. But for this one, you no need to go through that partial fraction method. You can write this like this, no? 1 by 3 by z, z minus plus, sorry, here minus. So I think you can do this with me, okay? And please do this with the understanding, okay? Don't just copy, don't, don't copy the writing, okay? Don't just copy what I am writing here, okay? Try to write it with the understanding, okay? Then if I do any mistake, you can see it, okay? Then you can help me to correct that one, okay? Because normally sometimes I make many numerical mistake, okay, when I'm doing a question, okay? Okay, so here you can write this as like this, 1 by 3 by 4 z minus 1, correct? Is this okay? Are you agree with me? Can I write like this? So here, if you get the common denominator, again you will have 1 minus z minus 1. No? You can get the common denominator as this one, 1 by 3 by 4 z minus 1, this part. Then as a numerator, you will come 1 minus z minus 1, correct? This is okay, no? Okay, I hope it is okay. Okay, thank you. Okay, so I think now uh, you may familiar with this one. Okay, you may familiar with this one. I think if you can remember the properties, you also think about this one also. Okay, So can you tell me what will be this? What is the inverse Z transform of this one? Can you tell me? Maybe you can't remember, or maybe you can remember. Okay. Actually, you no need to keep remember these things. Okay. For your exam, don't try to keep remember these things. Okay. Because this will be given. Okay. You can have a yes, yes, that is the one. Okay, that is the one. Okay, very good. Anyway, okay. So, so if anyone can't remember these things, anyway, don't worry about that. Okay. Only thing is, you should be able to evaluate uh, this kind of. If you can evaluate this kind of Z transformation, if you can evaluate is a transform of this kind of sequence, that will be enough. Okay. Okay. So I am not expecting to keep remember this. Okay. Because no need to keep remembering. No. Okay. Everything. If we know it, how to use, then you can use it. Okay. So, so this, if you have this knowledge, then it is okay. Okay. So actually, if I give this question, this question is not given by me. Okay. If I give this question first, as another part, I will give you to evaluate this one. Okay. I will give you evaluate this one, and then you can directly use this for this one. Okay. So I will be given this. Okay. I will be given this some time for evaluation. Okay. Can you understand what I'm saying? Okay. Okay. Now, can you evaluate this? Can you evaluate this? Okay. Okay. You can have a basic definition. Okay. And also you can use the property of Z transform. Okay. Property of Z transform. Okay. So say that, okay. Say that I have given this one. Okay. I have given you that the so here also you no need to keep all this remember. Okay. So anyway, I will if I given you this as a data. Okay. So un, if we get this a transform of un, I think you can remember that we have evaluate this. Okay. You should be able to evaluate this one. Okay. So you will get z minus 1. Can you remember? Okay. Okay. I can remember this. Okay. But I don't expect you to remember this. Okay. Because but I want you to evaluate. I want you to know how to evaluate this. Okay. So this is the basic function. Basic is a transform function. So you should be able to evaluate this using the definition. Okay. Okay. So this data I have given. Okay. And if I ask to evaluate this one, ANUN, using this, what is the answer for this one? Okay. So can anyone tell me what is the property you have to use here? This kind of property is there and we have discussed it. Okay. So what is the property we have used? Okay. I will show you the property list. Okay. I will show you the property list. If you can remember, you can ask me. You can tell me. Okay. So can you remember that we have a property table in our note? Yeah, is that one? Is there? So anyone can tell me what is the property we should use? Okay, this one. So this is the property table and which property we should use. Now I think you should be able to answer this one. Okay. Yes. Very good. I got one answer. Okay. Can anyone tell any other? If you have gone through the lectures or gone through the videos, I think you have the answer. Okay. So any one or two answer? Yeah. Yes, we have to do. We have to do this scaling is in Z domain. No, we have to use this property. Okay. We have to use this property. Okay, so this is scaling in time domain. Okay, so if you if you have a sequence, and if you have the Z transform of the sequence, okay, so if the sequence is multiplied by an, okay, so it will be a scaling in Z domain. Okay, so instead of Z, uh, we have to substitute a minus 1 Z. Okay, so that is the answer you should have. Okay, okay. So okay, so I keep this side to do the question. Okay, and this side for the approach. Okay, and here you have un. Okay, and un is given as 1 minus Z minus 1, and also if you can remember, the Z should be greater than 1. Okay, this is the ROC. Okay, this is the ROC of the un function. Okay, so for this value, if the Z is greater than 1, the magnitude of Z is greater than 1, then this uz, okay, so here we evaluate the uz. Okay, uz will be converged. Okay, so this z will be in a z plane, if you can remember. Okay, so if I draw the magnitude circle, it will look like this. Okay, so the radius will be 1. Actually, this is the unit circle. Radius will be 1. This is the unit circle. So ROC will be the greater than 1. So ROC will be this region. Okay, so ROC will be this region. Okay, okay. Now I have to find ANUN. Okay, so that is Z domain scaling. Okay, so instead of this Z, we have to apply. Okay, instead of this Z, we have to apply a minus 1 Z. Okay, instead of Z, we have to substitute this term. Okay, so here we have 1 Z terms. Okay, so we have to substitute these terms instead of Z. Okay, so instead of Z, I will substitute a minus 1 Z. So here total I have minus 1. Okay, so this will be my Z transform of this ANUN. Okay, so what is the ROC? Actually, I'm not expecting to keep remember this property also. Okay, I will give you the property list. Okay, and it is the open book test now. Okay, so you can use the property table. Okay, so you should have the property table, and you should be able to apply. You should be able to apply a property whenever it is needed. Okay, so that is the requirement. No need to keep remember all these things. Okay, so this is the ROC. Okay, so what is ROC? ROC is just scaling from the magnitude of A. Okay, just scaling with this magnitude of A. Okay, so what is the ROC will be? Okay, so here Z is greater than 1, and this one will be scaling also. Okay, so Z will be greater than magnitude of A. Okay, correct. So this will be my new ROC. Okay, so are you okay with this? If anyone have problem, you can ask. Okay, because if you can clear the problems here, I think it is better. Clear your Z transform problems. Okay, maybe numerical problems, maybe not. I can't clear all these things because those are not clear for me also. Okay. But Z transform related things you should be cleared at this stage. Okay. Okay. So I think this is okay. Okay. So this will be my ROC for this one. Okay. Now we will see, look at this one. Okay. So you can see that it is somewhat equal to this one. Okay. So if I write this, okay, AN, UN, okay. So Z transform will be, okay. So here, if I write this, AN, UN, okay. So Z transform is 1 by 1 minus, okay. Here it is plus, but here it is minus A Z. So A Z minus 1, okay. A Z minus 1, correct? Okay. So this will be the Z transform of this sequence, and ROC will be Z should be greater than magnitude of A. Okay. So this will be the Z transform and corresponding ROC. Okay. Now I have to get. Okay. So you can see that this is very much equal to this one. Okay. Only thing is the minus side here, minus sign here. Okay. So if I get 3 by 4 n un, what is my uh, Z transform? So you will have 1 minus 3 by 4 Z minus 1, correct? Okay, and yeah, Z minus 7. Okay. And the ROC will be Z should be greater than the magnitude of 3 by 4. So 3 by 4 is a real number. So no need to use the magnitude value. I just put the value here, 3 by 4. Okay. So this is the ROC, correct? Okay. So now I have to make this plus. Okay. So what is I have to do? Okay. So if I put here minus sign, okay. So this will be minus, okay, this will become minus 1 is at minus 1. Okay, so minus 1 will be plus. Okay, so you will have minus 3 by 4 is at minus 1. So this will become 1 plus 3 by 4 is at minus 1. Correct? Okay, so and ROC will be this one. No, same. Because here if I put minus 3 by 4, so I have to get the magnitude. So I have to get the magnitude only, absolute value. So it will be 3 by 4, no change. The ROC will not change. Correct? Is there any question? Okay, now I think we have found the Z transform of this part. Okay, the inverse Z transform of this part we have already found. Okay, so what is that actually? That is minus 3 by 4 n un. Okay, so this will be the, so I think we have already found the Z transform of this part. Okay, so it will be minus 3 by 4 n un. Okay, so this is okay un. Okay, so this is the Z transform of this part. Now we have to find the Z transform of this part. Okay, so how to find that part? So how to find that part? Okay, actually we are going to find the inverse Z transform. Okay, so we no need to find the ROC actually, but here I am telling you the ROC also to refresh your memory. Okay, to refresh your memory and to get a better understanding. But you should note that when we are evaluate the inverse Z transform, we are not normally focusing on the ROC. Okay, we will get this. We can get this in a Z transform time domain series, okay, the time domain sequence, it is enough. Okay, so what is the can anyone tell me how to find the Z transform of this one? Actually, there also I think you have to use a property. Okay, you can use a property for this one also. Okay, so here I will write the things here. So if you have this kind of one, un, okay, un, okay, then Z transform will be, Z transform will be 1 1 plus 3 by 4 Z minus 1. Okay, so this will be your Z transform. Okay, and corresponding ROC is there. ROC is Z is greater than 3 by 4. This will be your ROC. Z is greater than 3 by 4. Correct? Okay. 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 Now we have to find, okay. Now we have to find this one. We have to find this one. Okay. So I think that is also you can use a property. Okay. So we have this kind of one. Is at minus 1, 1 plus 3 by 4 is at minus 1. Okay. So here also you can use a property to get the time domain sequence. And what is the property you should use? Okay, here is the property list. Can you see which one we should use? So you can see that. Okay, yeah, I got one answer. Yes, very good. We have to use that one. Yes, good. Yes, okay. So I think I got some answer from 30203 student. Okay. Uh, there is a wrong. Please look at it again. We can't, the time reversal, we no need to use. We don't need to use the time reversal property. Which one? Okay, time reversal property is this one. So if you apply the time reversal property, here you have the Z transform, and instead of Z, we have to apply Z minus 1. That is our time reversal. Okay. So here, I think you no need to use that one. Okay, because you can see that. Okay, so so you can see that you can compare this one and this one. If you can compare this one and this one, what happened? This is multiplied by, so this part is multiplied by Z minus 1. Okay, so if I multiply this value, this is a transform. I think my writing may not clear. Okay, so I think you can, but you can understand this. Okay, so here also plus. Okay, so you can see that here, if I get the is a transform of this sequence. Okay, if I get this a transform of this sequence, it will be 1 by 1 plus 3 by 4 Z minus 1. Okay, and here, so I have a Z transform, another Z transform, that is 1 plus 3 by 4 Z minus 1, same part. And here it is Z minus 1. So what happened? This term is multiplied by Z minus 1. And I get this one. No? So which property, if we are using which property, we will have the multiplication. Check this again. So in which property we have a multiplication in Z. We have discussed that property. Okay. So can you remember that? Can you see that? we have xz there, okay, and xz should be multiplied by some z value, z minus 1 actually, okay. So this xz should be multiplied by some z value, z minus 1, z minus 2, like this, okay. So which property we have to use? Yes, yes, it is time shifting property, no? We have to use the time shifting property, okay. So did you get it? The one student gave me time reversal, okay. So is it clear for you, or should I explain it more? So one student gave me, yeah, I think, okay, no, okay. So I think you can understand. Okay. Thank you. Okay, so we will continue. So we have to use the time reversal property. Sorry, time shifting property. Okay. So what is time shifting property set? Okay. The time shifting property said that if you have some sequence, and if you have the z transform, it will be xz, okay. And if you shift the time by k, okay, to this side, okay, so you will get z minus k, the shifting value, okay. So here it is minus k, here also will be minus k. If it is minus 2, this will be minus 2, okay. And next is the is a transform of this xn, okay. So we can use that, okay. Directly we can use, okay. So here we have, z minus 1, okay. So here we have z minus 1, okay. And you can see that if we have multiplied by this z minus 1, okay, if I have multiplied this z minus 1, okay, okay, okay. So that means if I get the, so here it is z minus 1, okay. So if I time shift this by 1 to this way, okay, so I will get z minus 1, 1 divided by 1 by 3, 1 plus 3 by 3 z minus 1, no, okay. So I just get one time shifting, okay, to this way, okay. And I will have, so for the original one, this is the z transform, okay, that will be 1 by 3 by 4 z minus 1, okay. Now if I get the time shifting, okay, so this will be multiplied by z minus 1, okay, okay. So that is the exactly answer here, okay. Is it okay? Yeah, okay. I think I have done a mistake. Is this correct or not? Can you tell me? Is this correct? Yes, yes. Okay. Actually, here this n also should be shifted by 1, no? Because all this time n should be shifted by 1. Okay. So here I have to shifted this one also. Then I will get this answer. Okay. So this will be the Z transform of exactly. So this will be the Z transform, no? Okay. This one. Okay. So this will be this one, and we can have the corresponding time sequence for that one also, correct. Okay. And what about the ROC? Actually for this one you no need the ROC, okay, but for more understanding and to refresh our memory, okay, you can find the ROC for here, okay. For this one, what is the ROC for the original one? Okay, so this one, the ROC will be 3 by 4. ROC will be greater than, sorry, ROC is the magnitude of Z is greater than 3 by 4. Okay. Okay. So if I mark it on the Z plane, okay, so it is look like this. Okay. It's here. Okay. So if I mark it in the Z plane, on the Z plane, okay, that means on the complex plane, okay. So here we have real Z, and here we have imaginary Z, okay. So the Z is greater than 4, okay, that is the 3 by 4, sorry. Magnitude of Z should be greater than 3 by 4, okay. So that is the ROC for minus 3 by 4 in UN, okay. So this is the ROC for this function, okay. So if I mark this, okay, so if I draw this circle, okay, Z should be the magnitude of Z is equal to 3 by 4, okay. So this value will be 3 by 4, okay. So the ROC will be the region greater than this circle, okay. So the ROC will be this, okay, correct, okay. So this will be the ROC, and you can see that the infinity is there, infinity is with the ROC, but 0 is not in the ROC for this one, okay. So if we take time shifting, you can see that, okay. So XZ, okay, XZ. So for the time shifting Z transformation also have the same ROC, but Z is not, Z is equal to 0 if K is greater than 0, and Z is equal to infinity, K is less than 0. So what is here? K is greater than 0, no? K is greater than 0, no? In this case, in our case, n minus 1, the K is 1, okay, K is 1, no? K is 1. So K is greater than 0, okay. So Z equals 0 is not there, okay. Z equals 0 is not there, okay. And here for this one, the already Z is equal to 0 is not there, okay. So ROC will not change, it will be same, okay. So for this one also ROC will be, for this one also ROC will be Z greater than 3 by 4. Are you okay with this? Are you okay with this? The ROC, it is not needed for this question, okay. ROC no need to find, okay, but you can estimate the ROC using the property, okay. So you can see that if we get the original ROC, it will be greater than 3 by 4. So this region, okay, this colored region, okay, this dark region, okay. So so for this one, infinity is there in the ROC because it is outside here. So infinity is there, infinity is in ROC, but 0 is not in ROC, okay. When we doing the time shifting, it is said that if the shifted time K is greater than 0, okay, Z is equal to 0 is not in the ROC, and K is less than 0, Z equal to infinity is not ROC, okay. So we are in this case, okay. So K here, K is greater than 0. So Z equals 0 will not in ROC, okay. So 0 will not in ROC, okay. It is already not in ROC, you know. It is not, the 0 is not included in the ROC region of our original signal, okay. So the same ROC will be there, okay. Okay, I hope you get it. Okay, anyway, if you have doubt, you can ask me, okay. Correct. Now I think we have found the impulse response of the system Hn, okay. We have already found that one, okay. So if I write it, okay, so I have Hn, okay, Hn equal to minus 3 by 4 n un, okay, and here you have minus value, okay, minus value, and it is again shifted, no? So here you have minus, and you have minus 3 by 4 n minus 1 u n minus 1. So this will be your h, correct? Are you okay with this? So this will be your h. Okay. Is this causal or non-causal? Is this causal or non-causal? What is this? Is this causal or not? Yes, it is causal because it has only plus side. Okay, it has only plus side. This side only. Okay. So it is said that it is causal, no? So we can see that it is causal. It's a causal system. Okay. Actually, no need this data. Okay, but we can verify our answer through this, no? So it will be the causal signal. So we can have idea that our answer may be correct. Okay. So I think actually if I given this exam, I am not expecting the final answer. Okay. But if you can put the final answer, it is better. Okay. But if you have given a try, okay, if you have given a try, okay, at least if you try to use the partial fraction, and if you try to apply some property and try to get this Z transform, okay. So although your approach is correct or not, you will be getting some marks, okay. So don't worry, not in Z transform, okay. Also for the Fourier transforms and the discrete Fourier transform, you will be getting the same thing. Okay. Okay. So I think that is enough. Okay. And so we will. Okay. Now we have to find the yn. Okay. We have to find the yn. Okay. So before find the yn, okay. So we have xz. Okay. Okay. Now actually now you can see that. Okay. We have found the hn. Okay, we have found the hn. Okay, and also we have the xn. Okay, we have the xn. We already have the xn. Okay, so you may think that so we have xn and we have hn. So if we convert them together, you can get yn. Okay, so you may think that it may be easy. Okay, because there are no any set transformation. You can directly, if you can convol, if you can remember how to convol, okay, you can get the answer. Okay, actually this convolution we can write MATLAB program very easily. Okay, very easy to write a MATLAB program to perform the convolution. Then you can evaluate this y if you are doing a real engineering work. Okay, but for the exam, if you are not asked to do the MATLAB, you have to do it by manually. Okay, so then sometime it may be difficult. Okay, it may be difficult. So if you get any approach, that will be okay. Okay, that will be okay. Okay, but I hope Z transformation techniques may be somewhat easy. Okay, because we have to find the Z transform of this one only. Okay, actually Z transform of this one also we can get using the properties very easily. No, we can use the properties and we can get the Z transform of this sequence very easy. Okay, so once you get the Z transform, you can multiply them. Okay, then you will have the YZ. Okay, so now you have to find the yn, then you can get the inverse Z transform of yn. Okay, so I think that part is easy. Okay, but when you are going to evaluate the yn through yz, okay, if you are going to evaluate yn through this yz, sometime you will you should you may have to perform the partial fraction uh, simplification. Okay, that manipulation you have to do. Okay, so we will see whether we should do or we have to do. I hope we have to do that one. Okay, if the partial fraction is come, maybe I can't remember actually. Okay, how to find the partial fraction? No? So if it is a basic one, I can remember. Okay, I think in the above case we can, in part A we perform the partial fraction. Okay, but I am not sure this one. Okay, we will see. Okay, so okay, now I am going to find the xn xz. Okay, so now I am going to find the xz. So we have given the xn. Okay, so xn is equal to, so I think you have the idea why we are finding the xn. Okay, so this will be xn 1 by 3n un u minus n minus 1. 1 by 3n un 1 by 3n un, this is plus, no, plus u minus n minus 1, u minus n minus 1. So this will be our xn 1 by 3n un. Okay, 1 by 3n un plus u minus n minus 1. Right? So this will be our time sequence. Okay, now you have to find the xz. Okay, now you have to find the xz, and in this case you have to find the ROC also. Okay, because when you are finding the xz, the ROC is very important, and you have to mention the ROC. Okay, so you have to know if you know the basic procedure to find the ROC, you will get the mark. Okay, sometimes you will get the full mark. Okay, no need for a final correct answer. Okay, okay, but if you can have an approach, if you know how to get the approach, then you will get some marks. Okay, so don't worry. Okay, now can you find the xz through this? I think this one you can get directly, and this one you have to do some properties. Okay, and keep remember that already I have given this data. Un is equal to 1 minus z minus 1. Okay, so I have already given this data. Okay, so using this data and using properties, you have to evaluate xz. Okay, so can you take 5 minutes and try to do this? So then you can compare the answer with me. Okay, so use the property. Okay, I think this one you can get directly, and try to get this one also. Please have 5 minutes and try to do this. Okay, so I will do this. Okay, so you can see that you can directly get this one. If you have this one here, you have to do the what is called Z domain scaling. Okay, so you can get the answer, you can get it quickly. Okay, so this will be so here un, so you know that the ROC is so this will be given. Okay, this will be given. Sometime you are asked to evaluate this one. Okay, before coming to this stage. Okay, this will be given, or you are asked to evaluate this. Okay, so you should be able to evaluate this, and you should be able to use this to solve this one. Okay, no need to keep remember. So this will be Z should be greater than 1. Okay, the magnitude of Z should be greater than 1. Okay, please wait. Okay, I'm sorry. Okay, so we will do. Okay, so I think you can directly get this one. Okay, so here you have to do the Z scaling. Okay, so 1 by 1, instead of this Z minus 1, you have to apply 1 by 3 minus 1 Z. Okay, 1 by 3 minus Z. Okay, 1 by 3 minus 1 Z. So altogether you have to get minus. Okay, so this minus minus cancelled out and it will be plus, and this Z will be minus 1. Okay, so I will write it here directly. Okay, so you have minus 3 Z minus 1. Okay, okay, so what is the ROC here? ROC also will be scaled. Okay, so Z should be greater than 3 by 4. Okay, sorry, 1 by 3. Z should be greater than 1 by 3. Okay, so this will be the ROC and this will be the Z transform. Okay, what about this? Have you so do you have any idea? So what are the property we have to use? Can you tell me the properties? I think 2 properties you have to use. Okay, can you tell me the what are the properties? Can someone tell me? Hello, I hope you can hear me, no? Yes, good. Time shift. Yeah, no, I think, yeah, the answer is correct up to some level, but it is not scaling. You have to do the time shifting, but not scaling, I hope. Not the scaling. What is the, we have to use the time shifting, and what is other? So you can see that here minus values. Yes, time reversal and time shifting. No? So you can see here minus values. Okay. Yeah. I think it is a mistake. Okay. 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 So I think, so what I want to tell you is that if you have an approach, okay, if you have an approach, then you will get some mark. Okay, so no need to perform it. Okay, so these are all mathematics things. Okay, so if we are going to evaluate your maths knowledge, it is not uh, it is not good, no. Okay, because we need to measure your DSP knowledge actually. Okay. Okay, so actually, if I can realize, if you give a wrong, sometime by mistakenly you may be given the wrong answer. Okay, but based on the previous answer, I also can verify this may be a mistake or not. Okay, so you will get some marks. Okay. Okay, so here you have to use time reversal and time shifting. Okay, so we will see how to use them. Okay, actually, if you can remember, I think you haven't done the match filters, no? You haven't learned about the match filters. Okay, let's forget it. Okay, so you can see that. So for me, so you can have different approach, okay, as you wish. Okay, for me, okay, I would like to do the time shifting first and then time reversal. Okay, otherwise I will sometime I will confuse. Okay, so normally I'm doing that way. Okay, so uh, I have, so you can see that here we have minus n minus 1. Okay, so this is equal, if I write this like this, minus n plus 1. Correct, this is correct, no? Okay, so here also if you remove the brackets, okay, remove these brackets, it will be minus n minus 1. Is it clear? Okay. So I like this way. Okay, so you minus n minus 1. Okay, so I will write this like this, minus 1 n plus 1. Correct? This is correct. So if you remove the bracket, it will be minus n minus 1. Okay. Yes. Okay. Thank you. Okay. So I will be doing this. Okay. So you can see that here it is time shifting. Okay. Here it is time shifting, then time reversed. Okay. So you have un. Okay. So you have un. Un is 1 1 minus z minus 1. Okay, so this ROC will be z is greater than 1. Okay, so this will be the ROC. Okay, and okay, and so if I have u n plus 1, okay, so we will have z 1 minus z minus 1. No? Okay. So the ROC will be z. Okay, so if you can remember that if this n is less than 1, okay, if this n is less than 1, the infinity is not there. Okay, so here infinity is, we have the infinity, no? For this ROC we have the infinity, for this ROC we have the infinity, because we have the z is greater than 1, means you have the unit circle here. This is the region for ROC. Okay. So yeah, you can see that infinity is there. Okay, so within this ROC, infinity is there. Okay, but this n is less than 1. Okay, here the same ROC will be there, but z is equal to infinity is not in ROC. Okay, it's not in ROC. I think we have verified this. We have illustrated this using some example. Okay, so I think these are clear for you. Okay. If you can't remember, you can go through that previous example, then you can see this. We have discussed this. Okay, we have shown you how this happened, how this ROC is changing depending on the transformation using impulse function and simple function. Okay, so you can understand it. Okay, but here it is somewhat hard to understand. Okay, but you can use the theory. Okay, so here this will be the ROC. Z is greater than 1, but Z is equal, except Z is equal to infinity. Okay, okay, now I get the time reversed. Okay, so I get the time reverse minus n plus 1. Okay, so if I get the time reverse here, okay, so all these Z will be Z minus 1. Okay, so this will be Z minus 1, and this will be Z minus 1, so it will be Z. Correct? Okay, so this I will get this one. And if I get the ROC for that one, so this is the time reversal. Okay, so ROC will be 1 by 1 Z. Okay, so ROC will be 1 by R1. Okay, so that is mean, I think we have explained this. Okay, so you can remember. Okay, so if some XZ, if some XZ have a ROC, okay, ROC with some region. Okay, so if you get the time reversal XZ, okay, this value will be 1 by Z. Okay, so this value will be changed to 1 by this value. Okay, this value will be 1 by. Okay, so here the same thing happen. Okay, so now Z is greater than 1, but Z will be greater than 1 by 1. That means again it is z is greater than 1. Okay, because 1 or 1 is again 1, so z is greater than 1. Okay, and the infinity is not there. Okay, infinity is not there, but if I get the reciprocal 1 by infinity, now 0 should be not there. 0 should be not there. Z is equal to 0. Okay, so I think if you can't, if you didn't understand, okay, I think when I doing the part 1 yesterday, one student couldn't understand this. Okay, then I have explained this again to him using example. Okay, so if you are not clear with this, please refer that one, then you can get more understanding about this. Okay, now think and try to understand. Okay, if you couldn't understand this properly, please refer my the previous one. Okay, so I will upload the lecture today, so you can go through it and you can clear. Okay, so this will be our Z transform. Sorry, yeah, it's a transform. Okay, so this will be, okay, so we have found this one, and this will be z minus 1 1 minus z. Okay, and the ROC will be z is greater than 1 except z is equal to 0. I think here the z no is not there. Okay, z is equal to 0, not there, because z, the magnitude of z should be greater than 1. Okay, that means this area. So 0 is not there. This area 0 is not there. Okay, so actually we no need to write this part except z is equal to 0, because here z is so 0 is not there in ROC. Okay, so if we write like this, it is in. Okay, okay, now so now you have to use the linearity property. Okay, okay, so you know that if you have two transformation, you can add them. Okay, so we have add them. Okay, so this is linearity property. We can add them using the linearity property, no issue. Okay, linearity property. And what is the ROC? ROC will be the common space, no, using the linearity property. Can you remember? At least the intersection. Okay, so intersection should be there. Okay, maybe some values are there uh, without the intersection, but we can consider only the intersection here. Okay, because we have to give idea for this z, for this z value, this transformation will get finite value. Okay, not infinite value, finite value. Okay? So if we get the intersection, okay, so you know that for this one, the z is greater than 1 by 3. So this area, okay. And for this one, z is greater than 1. So that means this area, okay, this area. So what is the intersection actually? Can anyone tell what is the intersection? Okay, what is the intersection for both? What is the common area for both ROC? If you get the intersection, what is that? Yes, very good. Okay, so if you get the intersection, the ROC will be z greater than 1. Okay, so this will be the, because here greater than 1, it is common for this one also, no? Okay, and it is common for this one, but this intermediate section is not common for this one. Z is greater than 1, it is not in this circle. Okay, so this will be the common intersection. Okay, so this will be your ROC, correct? So you have find the xz and you have found the ROC also. Okay, so I think okay. Okay, now what you have to do? Now you have to find the yn. Okay, you are not going to evaluate the xz. Okay, you have to find the yn. Okay, Actually, I can remember that any student couldn't do this question, okay, in last year. I think not only one student, no any student do this completely, okay? Because there are many mathematical actually, okay? So there are many mathematical things. So actually no time to do this mathematics, no, within 2 minutes, 20 minutes. I think only for one question, you have only 20 minutes, okay? So to do this mathematics, I think it will take some very time amount, okay? Okay. So, so that is that, okay? So we have found the xz, okay? We have found the xz. Now we can find the yz, no? We can find the yz. Why? What should we have to? Using the convolution property, you can just multiply them, okay? So we will multiply them, okay? So this will be my xz. I will write it again here. 1 by 1 minus 1 3z minus 1 plus z minus 1 1 minus z minus 1 1 minus z. So this is my xz, okay? Now I have to multiply this by hz. So what is the hz? Okay, so you can get the common denominator and you can simplify this more, okay? But I'm not going to do so. So my hz will be 1 by z minus 1, 1 plus 3 by 4 z minus 1, 1 minus z minus 1, 1 plus 3 by 4 z minus 1, okay? 1 plus z minus 1, is it 1 plus? This is 1 plus 3 by 4 z minus 1. Okay, let's see it again. 1 plus 1 minus. Now 1 minus z minus 1, 1 plus. So this will be minus. Okay. So this will be minus. Okay. So this will be your yz. So now you have to evaluate the yn. To evaluate yn, how to find the inverse Z transform. Okay, so I think it is somewhat difficult. Okay, so let's try. So here yz will come. So I will multiply this one. Okay, so I will have 1 by z minus 1, 1 by 1 3 z minus 1. Okay, 1 plus 3 by 4 z minus 1. Okay, plus z minus 1, 1 z minus 1, okay, 1 by z, 1 by 1 plus 3 by 4 z minus 1, okay. So definitely you have to use the partial fraction, okay. So you have to use the partial fraction for this one. You have to use the partial fraction for this one, okay. So problem is that I think this one we can okay, I think if we get this back, okay, so it will be z1 minus z1 plus 3 by z, okay. So I think this partial fraction may be this, no? A 1 plus 1 by 3 z minus 1 plus B 1 plus 3 by 4 z minus plus. I think this is okay, no? I'm not sure actually. Okay. So you will have a 1 plus 3 by 4 z minus 1 plus b 1 minus 1 by 3 z minus 1. Okay, so this should be equal to this one, no? Sorry, this should be equal to 1 minus z minus 1. Okay, so then you have to apply some value for z. Okay, then you have to get some two equation with a b, then you have to solve that equation and you have to find the a value and b value. Okay, then I think you can directly get, okay, so this a will have one value and b will have another value. Okay, so you can get using the un function. Okay, so you have to, here you have a scaling and here also you have a scaling. Okay, so you can find the inverse Z transform of these two. Okay, so these terms you can evaluate like that. Okay, I'm not going to evaluate it because I'm not sure actually this one. Okay, if I evaluate and if this is wrong, it will waste your time also. Okay, that is why I am not going to use it. Okay, so if you have time, you can do this. Okay, you can practice. Okay, if you think it is good for your study. Okay. Okay, so you can do this as exercise. Okay, but in the exam I am not going to evaluate this one. Okay, so if I am going to do this, I will give you the correct expansion. Okay, I will give you the correct expansion and then you can do some mathematical things. Okay, so these are so these kind of mathematics you can do. No, okay, so these are simple mathematics. Okay, okay, so so we can find this one. Okay, in the same manner, I think this one will be, you can write this one as a by z plus b by 1 by z plus c by 1 by 3 by 4 z minus 1. I'm not sure actually this. Okay, this sometimes this get we have to get z minus 1 sometimes, so I'm not clear with that actually. Okay, for A level also I'm not doing the partial fraction part. Okay, so so you can find the ABC here. So this will be directly evaluate. No, this 3 will be directly evaluate. If you have ABC, you can directly evaluate this un. Okay, sorry, the time sequence. Okay, then you can evaluate the yn. Okay, but you have to do some mathematical things. Okay, simple mathematics, but not clear. I can't actually, I forgot the partial fraction methods. Okay. Okay, so I think you get the idea how to do this. Okay, is it okay? Okay, now we are asked. Actually, I couldn't. I am forgetting to do this part. Okay, so this is stable or unstable. We can express using the pole zero plot. Okay, so if you have if you so if you can find the poles and zero, you can find the poles and zero. Okay, so you have to find the poles and zero actually here. Okay, for hz you have to find the poles and zero. Okay, so impulse function you can find the poles and zero. So what you have to do that. Okay, I think we can do this one. Okay, so I will do this. Okay, so so they are asking the system is stable or not. Okay, so what is the system is depend on what? The system characteristic is depend on it transfer function. Okay, so this will be its transfer function or impulse function. Okay, hz. Okay, when it is in z domain, sometimes z domain or frequency domain, we are called it transfer function. No? Okay, so hz will be yz divided by xz. So sometimes this is called transfer function. Okay, or this is the z transform of impulse response actually. Okay, both are okay, both terms. Okay, so this is the characteristic. Okay, so if I find the pole and zero here, I think you can find the poles and zero. Okay, so I think you are okay with this yn. Okay, you can find the yn through this method. Okay, so what is you have to do is you have to do some mathematical manipulating. Okay, so please do it as exercise. Okay, then you can get the value. Okay, so now I am focusing on the HZ. So this will be my transfer function. So what is the transfer function? It will be 1 Z minus plus 1 by 3 by 4 Z minus, no? 1 minus Z minus 1 plus 3 by 4 Z minus. Okay. So this will be 1 minus. Okay, so this will be 1 minus. Okay. Okay. So to find the poles and zero, I think it is better to, if you can write this like this, okay? So you can write this as Z minus 1 divided by Z plus 3 by 4, okay? Correct? So Z and Z will be cancelled out. So here you get Z and here you get Z by Z you cancel out and you will get this one. Z minus 1, Z plus 3 by 4. Is it okay now? Okay, so I just get the reciprocal. Okay, so here you have 1 minus 1 by Z. So you can get common denominator. So you have Z minus 1, Z here. And here you can get by Z. So you have Z plus 3 by 4. Then Z cancel out. Okay. So you will get this one. Okay. Now you can find the poles and zero. No, what is the, can you find what are the poles and what are the zero? To find the pole, you have to equal this to 0 to find the zeros. To find the pole, you have to equal this to 0. Okay, so if you equal your numerator to 0, you will get zeros. So Z is at 1, you will get 1 0. Okay, so if you, so these are the zeros. To find the poles, you have to get Z plus 3 by 4 equal to 0. Yes, thank you. All minus 3 by 4, no? Okay. So your pole will be minus 3 by 4. Okay. So you have two poles and two zeros. Okay. So if I plot it, okay, plot it, okay. So at Z equal 1, you have 1 0. So here you have a 0. And Z equal 3 by 4. So here in this area, you will have 1 pole. Okay. So if you draw actually I'm not doing this part. Okay, now you can get it. Okay, so if you draw a circle, unit circle, okay, if you draw a unit circle like this, okay, so if all poles are inside the unit circle, we called that system is stable. Okay, so all poles should be inside the unit circle. So if I draw a unit circle with the radius 1, okay, so I cross this pole, no? Okay, I cross this 0 because 0 is at 1, okay, and this pole is here, it is about 3 by 4, okay, in this area. So the pole is inside the unit circle. Okay, so if the pole is inside the unit circle, we called it stable system. Okay, otherwise, if any pole is outside this circle, that system will be unstable system. Okay, and if any poles is here at the unit circle, we called it marginally stable. Okay, so please keep remember that 3 point. Okay, using the poles and zero plot, we can evaluate a system is stable or not. Okay, so if all poles are in unit circle, the system is stable. If any pole outside the unit circle, then system will be unstable. Okay. If any pole is on the unit circle, it is called marginally stable. Okay, marginally stable. So please keep remember these things. Okay, if you can remember using the using Laplace transform also, we can say the system is continuous time system is stable or not. If the poles and zeros are in right hand side, we called, I can't remember exactly, we called it stable. No, if it is left hand side in this way, minus side, it is unstable. And if it is on this imaginary axis, it is marginally stable for the S domain, okay? For the Laplace transform. But for the Z domain, it is like this, okay? Okay, did you get this? Okay, I hope you get it, okay? So try to do this by yourself, okay? I'm not going to do that, the second part, okay? Because the second part type question will not come to your exam, okay? So I will I will uh, I will ignore it. Okay, I will skip that. Okay, so we will do one or two question in the assignment. Okay, because Dr. Udesh asked to do so. So I